Welcome to our YouTube channel. This is Ernest coming to you from MathLab Tutorials in Toronto, Canada. Although seemingly impossible, our mission is to transform some of that destructive hate energy into constructive love energy. Mathematics is part of all that surrounds us. Just pause and take a good look. As your screen suggests, like it or not, math really did take us from the Stone Age to the Space Age. The sermon is over. Now let's get down to some serious math. This will be video number 7 of the Algebra series, and we're going to continue looking at HTF problems, hard trinomial factoring problems. Again, we're looking at a problem of the form GCF times HTF. And the GCF is on the outside, and the hard trinomial factoring part is on the inside. And the a this time will not be equal to 1. When the a is equal to 1, we have an ETF, easy trinomial factoring. When the a is not equal to 1, the factoring becomes more difficult, and we call it HTF, hard trinomial factoring. So let's have a look at this question here. We have 18x squared minus 54x plus 40. Certainly this is a quadratic polynomial. And we look for a GCF. When we look at 18 minus 54 and 40, the GCF is 2. And then we put it out front. And then we use division to find the balance. 18 divided by 2 is 9, so we put down 9x squared. Minus 54 divided by 2 is minus 27, so we put down minus 27x. And 40 divided by 2 is 20. And now the GCF just remains outside. It's not bothering anyone. Just leave it alone. If we examine the inside of the brackets now, we have our quadratic coefficients. It's 9, negative 27, and 20. So we identify this as an HTF because the 9 is not equal to 1. Okay, so this factoring is a little bit harder, and we're going to use the HTF chart over here or the ABC chart over here. The quadratic coefficients are 9. Just put it down. Negative 27, put it down, box it in, and put down 20, put it down. Only box in the B term. Okay, the next thing we do is look at all the numbers that multiply to give you 9, starting with 1. So 1 times 9 is 9, we're good to go. And then 3 times 3 is 9, we're good to go, and we're finished. Let's look for all the numbers that multiply to give you 20. Always start off with a 1. We have 1 and 20, and then 2 and 10, and then 4 and 5. These numbers inside the brackets all multiply to give you 20. Notice that the top is always increasing, and the bottom is always decreasing. The top is always increasing, and the bottom is always decreasing. That's the way I like to do these. Now that we've put all our factors down over here, it's time to focus our attention on that 27. Okay, we need to get a good match for 27. We need to match a left bracket with a right bracket to give us 27. Usually I work the chart bottom up. So I focus on the 3 and 3 and 4 and 5. I try to do a parallel match. 3 times 4 is 12, and 3 times 5 is 15. Is there any way to add or subtract 12 and 15 to give you 27? And the answer is yes. Absolutely yes. If we try to do a crisscross, we get the same thing. We get 3 times 5, which is 15. 3 times 4 is 12. So it's the same deal. So it doesn't matter. So let's concentrate on the parallel match. 3 times 4 is 12. 3 times 5 is 15. Put it down. Now, don't put the signs down. These two numbers have to add up to negative 27. To do that, you have to have a minus 12 minus 15. The last thing you do over here in terms of the chart is multiply these two signs together. A negative times a negative is a positive, and C is also positive as well. And that's how you know for certain you're on the right track. Don't forget to verify. Negative times a negative is positive, which carries the same sign as the C term. You must do that, otherwise you will make mistakes using chart factoring. Okay, that's what I call this. I call it chart factoring for HTF problems. Okay, so now we have the negative 12 minus 15, and we're good to go. We're done with the chart for the time being. Next, what you do is go back here, drop the 2 down because that's GCF, and open up 2 empty bins. Empty. Do not put anything inside the bins. Now we go back here. Remember we did 3 times 4 and 3 times 5. Okay, so we did a parallel match. 3, 4, 3, 5. So now we look at the opposite. We look at the crisscross. We get 3x and 4, drop it in, and we get 3x and 5, drop it in. So you always do the opposite of what you did to get these numbers over here. We did 3 times 4 is 12. 3 times 5 is 15. I call that a parallel match. So when you put the numbers down over here, you have to do a crisscross. Okay. On the other hand, if you would have done a crisscross over here, then when you put the numbers down over here, you have to do a parallel. Okay. So now we have 3x and 4, 3x and 5. Don't put the signs down. Now I'm going to do an inside-outside to put the signs down. 4 times 3, that's the inside. 4 times 3 is 12, and we need a minus 12. So you put a minus sign there. And then the outside, 3 times 5 is 15, and we need a minus sign. So that's minus 5. That's how you figure out the signs. Don't put the signs down originally. Leave it blank. Just put the numbers down. Okay? So that's the end of the problem right there. That's factored form. It factors as 2 bracket, 3x minus 4, 3x minus 5. And SpongeBob is certainly approves. Okay? Let's go on to the next question. This appears to be a GCF.HTF, but with 2 variables. So it's a GCF.HTF, but with 2 variables. It's going to look something like GCF on the outside, and we're going to have an ax squared plus bxy plus cy squared on the inside. And the a value will not be equal to 1. That's how we know it's an HTF. If this a value is equal to 1, then this becomes an easy trinomial factoring, and we don't have to use this chart method to do it. Okay, so let's look at the problem over here. This is the actual problem down here. That's just the header for the problem. So we have a 30a to the 4th dot b cubed minus 52a cubed b to the 4th minus 42a squared b to the 5. And of course, there certainly are 3 terms. Let's try to identify what the GCF is. 30, 52, 42, the GCF is 2. That's the largest common factor is 2. Next, the lowest power of a to the 4th, a cubed, a squared. Lowest power is a squared. Lowest power of b cubed, b to the 4th, b to the 5th. B cubed is lowest power. So now we just finished building up the GCF as 2a squared dot b cubed. We pick it up, put it on the outside, out front. And then we open up a big empty bin over here because we need to figure out the balance. And of course, the balance you always figure out by taking the term divided by the GCF. And we do that term by term. Term 1 divided by the GCF will give you 15a squared. Term 2 divided by the GCF will give you minus 26a dot b. And term 3 divided by the GCF will give you minus 21 dot b squared. You can do that slowly if you wish. It's just using exponent laws. That's all it is. Okay, so the GCF remains out front. If we look at the inside over here, we see 2 variables certainly, and we identify this as a 2-variable quadratic. And also, the number in front of the a squared is 15, which is certainly not equal to 1. So we have an HTF problem on our hands. It's a 2-variable HTF. So now we go over to the chart over here. You identify the quadratic coefficients as 15 minus 26 minus 21. There it is, 15 minus 26 minus 21. And now box in the negative 26 because that's the objective. The idea now is to find all the numbers and multiply to give you 15. So we start off with 1 and 15, and then we proceed to 3 and 5, and we've exhausted all the factors. Let's look at all the numbers and multiply to give you 21. Remember that you disregard the minus sign. Don't worry about the minus sign. Okay, if you bring the minus sign down, it's just going to complicate your life, believe me. Okay, just worry about the 21. Let's look at all the numbers and multiply to give you 21. It's 1 times 21 will certainly give you 21, and 3 times 7 will give you 21. So we're done in terms of the A column and the C column. Our job is to focus on the B column now. Okay, I usually run this bottom up, and I try to do some matches. The objective is to get 26. Let's try a parallel match. We get a 3.3 is 9, and a 5.7 is 35. Now 9 and 35, any way to get a 26? Yes, indeed. Absolutely. If we would have tried it the other way around, if we would have tried a crisscross, 3 times 7 is 21, 5 times 3 is 15, 21 and 15, 21 and 15. Any way to get 26? Absolutely not. Any way to add or subtract 21 and 15 to get 26? No chance. Okay, so I think we hit the nail on the head the first time around. So we get 3 times 3 is 9, put it down. 5 times 7 is 35, put it down. Now these numbers have to add to give you negative 26. In order to do that, you have to put a minus sign in front of the negative 35 and a plus sign in front of the 9, because minus 35 plus 9 will certainly give you minus 26. So now at this stage, just leave it alone, and you drop down the GCF down here, open up a big empty bin here, and a big empty bin here. Okay? So now this is what we do in this case. Do you recall that to get these numbers in here, we did a 3.3 and a 5.7. 3.3, 5.7. That's a parallel match. To put the numbers down, we have to do a crisscross. So we're going to do 3A, 7B. There it is, 3A, 7B. And 5A, 3B. 5A, 3B. Don't worry about the plus and the minus for now. Okay, let's go over it again. 3 times 3 is 9. 5 times 7 is 35. So we did a parallel match to get these numbers. To put the numbers down, these numbers down, what we're going to have to do is the opposite. We're going to do a crisscross. So we get 3A and 7B grouped together, and 5A and 3B grouped together. Now that you have that without the minus and the plus, we're going to do an inside-outside in order to locate or to identify the signs. Let's do the inside first. 7 times 5 is 35. We need a minus. So you put a minus sign there. And then we'll do the outside. 3 times 3 is 9. We need a plus sign. So you put a plus sign there. So now altogether we have 3A minus 7B, 5A plus 3B. And there's a GCF out front. And SpongeBob is happy, so I think we're done with that problem. That's the factored form. Let's go on to the next slide. This is about DOS factoring, difference of squares. Whenever you see a squared minus b squared, which I normally joke with my students, I say apple squared minus banana squared, because the apple and banana stand for anything. When you see an apple squared minus a banana squared, that indicates that you have a difference of squares. There's the difference right there. And these are both perfect squares. And that's why it's called a difference of squares. So that's a difference of squares in standard form. Now, what's normally the difference of squares formula, for factoring formula anyway, usually is presented like this. It's a squared minus b squared, where the a and the b can be anything, is equal to a minus b times a plus b. Notice that these are called conjugate pairs. So a difference of squares factors as conjugate pairs. If you were to re-expand the right-hand side using bullet, bullet, target, target, you get a dot a, which is a squared. There it is. And then you get a dot b minus b dot a. They cancel. And then at the end, you get minus b dot b is minus b squared. So this is, in fact, an identity. Okay, these factoring formulas are identities. Another way to write this is this way. Okay, it amounts to the same thing. Okay, a squared minus b squared can always be written as the square root of a squared minus the square root of b squared times the square root of a squared plus the square root of b squared. Okay, it can always be written like that. Okay, because the square root of a squared is a, the square root of b squared is b, the square root of a squared is a, the square root of b squared is b. This part over here is, this is a different way of doing it, and it makes it easier for students to factor. Okay, and anyway, the whole objective over here is to find the square root of a squared, to find the square root of b squared. Let's go on to the next slide, and we'll see how that's done. This is question 10e. It says use the greatest common factor together with DOS in order to factor. So the first thing I notice over here is that we have two terms with a minus sign in between. That indicates that this is probably a good candidate for a DOS. Okay, so I notice two terms, but I also notice that it has a GCF of 9, because the GCF of 36 and 9 is 9. Also, I notice that, whoa, I did something wrong over here. Oh, what are you going to do? I think this should have been a y to the fourth, okay? So anyway, copied it down wrong. It should have been a y to the fourth, so just pretend for the time being that it's y to the fourth. I've got it down here. It's okay, I might fix it up in a future video, but anyway, it's y to the fourth. So you factor out the GCF, which is 9, and then to get the balance, you do term divided by GCF, 36 divided by 9 will give you 4, so you get 4x to the power 8, and then minus 9 divided by 9, you'll get negative 1, and then you'll get y to the power 4. Don't forget that used to be y to the power 4. My mistake. Now, if you look inside, that's GCF, so you're not going to touch that. The inside of the brackets over here is, in fact, a DOS. It's a difference of two perfect squares. Okay? And then this is like the a squared term, that's the b squared term. We're going to take the square root of a squared, which is a. Okay, the square root of 4 is 2. The square root of x to the power 8 is just x to the power 4. To find the square root of x to the power 8, all you need to do is divide the exponent by 2. That's how you find square roots. Divide the exponent by 2. And then the square root of y to the power 4 is just y squared. And so we have this. In the next line, we write down equals 9, bracket a minus b, a plus b. And then just drop in the a and the b in the next line. Okay, so drop the 9 down. The a and the b are right here. We have a 2x to the power 4 minus y squared and 2x to the power 4 plus y squared. Okay, this over here, it's really a sum of squares, so it does not factor. This is almost the difference of squares except for the 2. Okay, so we won't bother. If we wrote 2 as a square root of 2 all squared, we can treat this as a difference of squares. But we won't bother doing that. Had that 2 have been a 4 or a 9 or something like 16 or 25, then I would have done another DOS right here. But when it's equal to 2, the square root of 2 is irrational, and therefore we're going to leave it alone. We'll declare this to be the factored form. Okay, let's go on to the next slide. Same sort of example. It's a GCF.DOS problem. If we look at it, we've got two terms. and we've got a minus sign in between. We've got a bunch of even exponents over here. 4 is a perfect square, 9 is a perfect square, and I think we have a DOS problem on our hands. But the first thing you need to do is to factor out the GCF. You see 4 and 9, the GCF is just 1, so there's nothing to do. Now, what's the lowest power of a? We have a squared here, a to the 4th, the lowest power is a squared. The lowest power of b, we have b squared, b to the 4th, the lowest power is b squared. So we've just finished building up the GCF as a squared dot b squared, and as usual we put it out front and we divide in order to find the balance. Term 1 divided by the GCF will give you 4. Term 2 divided by the GCF will give you 9a squared dot b squared. And if we look at the inside of the brackets over here carefully, 4 is a perfect square, 9 is a perfect square, and a squared b squared is also a perfect square. So this is a DOS problem. This will be the a squared term, and that's the b squared term. The square root of a squared, if we do the square root of 4, you get 2. The square root of 9, you get 3. The square root of a squared, you get a. The square root of b squared, you get b. Okay, so there's the a and the b. So in the next line, we drop down the GCF, which is a squared dot b squared. And of course, DOS always factors as capital A minus capital B times capital A plus capital B. So it's 2 minus 3 dot A, 2 minus 3A dot B, and then 2 plus 3A dot B. So we get 2 minus 3A dot B and 2 plus 3A dot B. And there's nothing more to do over here, so we declare that to be the factored form. Okay, let's go on to the next slide. Again, this is another GCF.DOS problem. We identified 2 terms, and there's a minus sign in between. 9 is a perfect square, 36 is a perfect square. These are all even exponents, So chances are very good we've got a DOS problem on our hands. We look for the GCF, look at 9 and 36. The GCF is 9, put it down. We look at the lowest power of x to the 4th, x squared. Lowest power is x squared, put it down. And we look for the lowest power of y. We have y squared, y to the power 6. Y squared is the lowest power, put it down. And we've just identified the GCF as 9x squared dot y squared. Again, you put the GCF out front. And our job is to find the balance. To find the balance, we're going to divide. Term 1 divided by the GCF will give you x squared. Term 2 divided by the GCF will give you minus 4y to the power 4. And if we look inside the brackets over here, we identify this as a DOS. This is a perfect square. 4 is certainly a perfect square. And y to the power 4 is a perfect square. Why? Because this exponent is even, and that's even. Okay? So again, we do the square root of x squared is just x. The square root of 4 is 2. The square root of y to the power 4 is y squared. And in the next line, we drop the GCF down, open up 2 empty bins, and then drop down an x minus 2y squared. There it is. And x plus 2y squared. There it is. If you look at this carefully, that does not factor, and that does not factor. That means we are done. Okay, so that's the factored form. Let's go on to the next slide. And this is a, you know what, we'll just leave this for now. We'll go into another video for this, okay? I don't want these videos to become too long. Thanks to all for viewing this video. Stay tuned for many more videos to come. If you liked the video, please give us a like, submit comments, and subscribe to our channel. If not, please tell us how to improve it. Over and out from MATLAB Tutorials in Toronto.